Morning class. So yesterday we have done all this delta G delta is equal to delta H minus T deltas, and we understood that at what temperature we have to keep so that this will be spontaneous or non-spontaneous. Okay, so now we will have some questions. We will do some questions and then we'll move to next thing. So there I have written two questions, that is, for the melting of ice at 25 degrees Celsius, the enthalpy of fusion is 6.97 kilojoule per mole, and the entropy of the fusion is given over here, that is 25.4 joule per Kelvin per mole. So what thing I want to say, that is, they are the two different unit. ये unit बहुत ध्यान से देखेंगे. This is 6.97 kilojoule per mole, but if you talk about the entropy, it is joule per Kelvin per mole. So don't forget to change in the same unit, okay, otherwise it will be wrong. Calculate the free energy change, and so you know that delta H is given what it is. Let me use the blue pen. 6.97, yes, that is kilojoule per mole, and delta S is equal to 25.4 joule per Kelvin per mole. So what I will do, I will convert delta H into joule. So for this I will multiply by 1000 and we will get 6970 joule per mole. Got it here? And this is already in joule. So okay, then what you have to find, calculate the free energy change, that means delta G you are supposed to find, and we have formula. Delta G is equal to which equation it is? Gibbs-Helmholtz equation, isn't it? So delta G is equal to delta H minus T delta S. Just put the value and you will get this temperature, what the temperature you will take. So it is 25 degrees Celsius. So delta T is like, T is given 25 degrees Celsius. So what you have to do, you have to convert this into Kelvin. So this is 298 Kelvin. Got it here? Okay, so now put the value and simply we will get the answer. So delta H is equal to what it is? 6970 minus temperature is here 298 and delta S is here 25.4. So just same unit, so there is no problem at all. This will be joule per Kelvin per mole. This is joule per Kelvin per mole, and you have multiplied by Kelvin. So Kelvin and per Kelvin will be cancelled out. So this is also joule per mole and this is also joule per mole. So unit are same. Okay. Now just solve this and you will get it. So once you will multiply by this thing, you will get 7569.2. Okay, and that is joule per mole. Now this subtraction and you will get minus 599.2 joule per mole. So this is the answer of this question. Hope you got it. This is very simple question, just to know the things, that what is given and in which unit is given. So you have to convert the unit also. That is for sure. Here is the next question I have written, that is, for a reaction 2NO gas plus O2 gas changing to 2NO2 gas, the enthalpy and the entropy changes are 113. That means enthalpy, let me write over here, the enthalpy is delta H, and that is 1130 kilojoule per mole. And along with this, entropy is also given, that is delta S is equal to minus 145 joule per Kelvin per mole. Again the same problem, here it is kilojoule, here it is joule. So what I will do, will multiply by 1000 and it will convert into minus 1130 joule per mole. Got it? Okay. So now find the temperature at which this reaction is spontaneous. So that much is given, and now you have to find the temperature at which it will be spontaneous, to be spontaneous. Yes, and in this case, got it? So what we want, we have to put the delta G negative. We have to bring delta G negative. Got it? So how to find this? This is like you have done if it is in equilibrium. Okay, it is said that it is in equilibrium. So enthalpy and change respectively the temperature at which this reaction is spontaneous. So consider karenge that it is equilibrium. So if we talk about since delta G is not mentioned, so we will, like it is asked na, find the temperature. किस temperature पे spontaneous होगा, मतलब right now this reaction is stopped, isn't it? So reaction कब stop होगा? When the delta G value is 0, that means it is at the equilibrium. Okay, so since it is asked, so you can write here that delta G is equal to delta H minus T delta S. And if you don't want to do this, so that the simple formula also you can use, we have done once, that is delta H is equal to T delta S, last to last video. Yes, so from there you can find. So delta G, since reaction पूछा जा रहा है, so we will assume that delta G is 0. So here delta H minus T delta S, so we will get that delta H is equal to T delta S. So we want the temperature, so T will be delta H upon delta S. And the reaction should be spontaneous. Yes, so वो जो भी टेम्परेचर रहेगा above this, क्योंकि इस टेम्परेचर पे अगर ये जो टेम्परेचर हम निकालेंगे, that at this temperature the reaction is at equilibrium, it is not going to move anywhere. But if we will increase the temperature more than that, whatever we will get, then it will be like it will move. So delta H is given here 113. This is 113 kilojoule per mole, no? 113 kilojoule per mole. So if, okay, sorry, it is 113, so it will be different. This will be 1000 multiply करेंगे तो you will get 000, isn't it? 113,000, that is minus, okay, and delta S we got minus 145. This is, if you'll keep the unit, this is joule per mole, and this is joule per Kelvin per mole. So this joule cancel, per mole cancel, this Kelvin will come up, so it will be Kelvin come. So just solve this and you will get this. It is 779.3 Kelvin. So you can write that at 779.3 Kelvin, the reaction is in equilibrium. That means it is neither moving in forward direction nor it is moving in backward direction. This reaction is like it needs some initiation. It is in equilibrium. Got it? So what we have to do in this case, to proceed the reaction in the forward direction, we have to increase the temperature. We have to increase the temperature, because 1 second. Yes, we can. We could have said this thing that it more than this. But one thing you have to keep in your mind, that's delta H is in negative. That means it is an exothermic reaction. So if we will increase the temperature, the reaction will move in the backward direction. Are you getting it? समझ में आई बात? So if it is supposed that delta H positive होता, तो you can say that it is more than 779. If we will increase the temperature above this, the reaction will move in the forward direction. So that is the concept. But after before writing all this, you have to check that delta H की value क्या है. It is in negative, यानी कि this reaction is in exothermic. It is exothermic. So if it is exothermic, what we have to do? We have to lower the temperature, because exothermic के लिए high temperature is not favorable. So reaction is in equilibrium, and hence to proceed in forward direction. To proceed in forward direction, the temperature must be less than 779. The temperature must be less than 779.3 Kelvin. Why it's so? As delta H is negative, that means the reaction is exothermic, and for the exothermic, low temperature is favorable. Got it here? So this is the answer. Now next topic we have to start, and that is physical significance of Gibbs free energy. That means, what is the physical significance of Gibbs free energy? Gibbs free energy, I have explained that it is the energy, maximum energy to do the useful work. So now what is the significance? This whatever the derivation I'm going to do, it will never be asked. Just for knowledge I'm telling you. Okay, so see, according to first law of thermodynamics, we very well know this, Q is equal to delta U plus W, isn't it? Here what I'm going to explain, that W can be expansion, W कैन बी नॉन एक्सपेंशन, मतलब वर्क डन जो है वो एक्सपेंशन भी हो सकता है, नॉन एक्सपेंशन भी हो सकता है. सो व्हाट आई एम सेइंग, मैं यहाँ सोच रही हूँ, आई एम अज्यूमिंग दैट in this work done there is a both expansion work is also there and non-expansion work is also there. So can I write like Q is equal to delta U plus W expansion plus W non-expansion? Just assume किया जा रहा है कि that both the work are there. I will write over here. Okay, so this is now we know that W expansion का formula क्या होता है, PdV. Yes. So we can write delta U plus PdV, Q plus W non-expansion. Any problem in this? Yes. Now this value is what? What can we write for this value? We can write delta H, because we know that as delta H is equal to delta U plus PdV. We know that, we have proved already, dV. So delta H I am writing plus W non-expansion. Any problem in this? Yes. Now delta S, अगर अभी हमने and whenever we have studied that entropy, so we know that for a reversible change at constant pressure, at constant temperature. Okay, so we have learned that Q reversible is equal to T delta S, or we can write, yes, we have done delta S is equal to Q reversible upon T, so that I can write Q reversible is equal to T delta S. Can I write? Yes. So can I put this Q reversible here in this formula? So I can write, because this is the reversible equation, so we can write delta, this is equation. So from equation 1 I can write, from equation 1 Q की जगह पे I can write T delta S is equal to delta H minus plus work non-expansion. Yes, any problem? Okay, now just, okay, so I can write like delta H minus T delta S form I want to like bring. So can I write like W non-expansion is equal to delta H minus T delta S, or we can say that instead of this I can say delta G. So delta G is equal to work non-expansion. Can I write? Yes. Or delta G is equal to minus work minus delta G. Let me bring this side, and this will be work non-expansion. Work non-expansion. Can I write like this? अब इससे होगा क्या? Why I have done? So this can say by this way we can say that there is a decrease in free energy of the system minus delta G. ठीक है? In a process, if it is the if we want the maximum useful work done by the system, because it was negative, got it? So if we consider that maximum work done जो है वो by the system कितना होगा, so that will lead to decrease in delta G. Are you getting it? So according to this we can say that, the decrease in delta G of a system is the measure, or is that value, we can say measure of maximum work done, maximum useful work done. You write it or not, don't worry, useful की ज़रूरत नहीं भी होती है. Maximum useful work done by the system. समझ में आ गई बात? So this is by the system. That's the reason हमने ये proof just किया कि अगर हम work done निकालते हैं maximum work done, तो that will lead to decrease in the gives free energy. Got it? And due to this reaction will be spontaneous. Okay, तो ये तो दिया हुआ, but हमें इन सब फॉर्मूला को ज़्यादा यूज़ नहीं करना है. क्लास 11 में we have one formula for electrochemical cell. Okay, and that formula will be asked in class 12th also, so that you have to learn. So it says that in case of any electrochemical cell, जो useful work done होता है वो electrical work होता है. Okay, and अगर E हम assume करते हैं as EMF of the cell and N is the number of moles of electron involved in that cell, then electrical work will be, let me use the blue pen, black pen. In electrochemical cell, the maximum work done is electrical work. Okay, and this electrical work जो होता है that is वहाँ पे explain ऐसे किया था कि that is equal to जो electrical work होता है वो होता है NF E0 cell. अब ये पूछो कि what are all this, I'm just going to tell you. So we can write, so there is a formula because maximum work done is equal to delta G, isn't it? And delta G is negative, so delta G negative, and this is NF E0 cell. Or you can write the formula delta G is equal to minus NF E0 cell. This is the formula you have to learn. Out of this, in this, what is this? F is Faraday, and Faraday की value होती है 96500 coulomb. Okay, that you have to learn. E0 cell जो होगा वो होगा reduction potential, and इसकी value you will be given to you, reduction potential. And what is this reduction potential you will better understand in class 12th electrochemistry. So leave it for now. So E0 cell, just learn this value. E0 cell is called reduction potential, and in the question if it is asked it will be given to you. And N is equal to number of moles lost, or number of moles of electrons. Let me write moles of electrons lost or gained, or which involved in the reaction. Lost or gained. Got it? So there will be questions on this topic also that you have to learn. There is one more formula with the standard free energy that we will do in that equilibrium constant. So we will also do. So before that, okay. So now let's understand about the Gibbs energy change and equilibrium constant. So let me explain in form of a graph. Like it's a Gibbs energy. This is y-axis is Gibbs energy. This is for reactant and this is for product. When we see the graph, we get like this. Okay, so it says that if the graph is towards the product, if you talk about towards the product like this, yes, so in this side, यहाँ जब product की side होता है तो K will be towards the product, then K will be more than 1. Clear? Because equilibrium constant जो होता है, that is equilibrium, let me write equilibrium constant, that is the concentration of product upon reactant. Concentration of reactant. Okay, so if product is more towards the product, if it is more, so obviously Kc value will be 1. Okay, so let me write this point. If this is called minima, okay, minima कहते हैं, नीचे की तरफ जो ग्राफ आता है. So if the minima in the curve is towards product, that means product amount is more than the reactant, and in that case K will be greater than 1. Okay, second point, if the minima in the curve is towards the reactant, if minima in the curve is towards reactant, here I have written here if the minima in the curve is towards reactant, okay, reactant, that means reactant amount is more, so obviously K value will be less than 1. Yes, and if the minima is in the curve in between, यहाँ पे अगर suppose that this is the in between, so this condition is called equilibrium. Okay, तो ये कहलाएगा, this will be equilibrium mixture, and ये जो energy होगी, this is called Gibbs, ये जो minimum Gibbs free energy होगी, तो this is called minimum Gibbs free energy. Got it? And like direction is, this is the direction. अगर हम यहाँ पे बात करते तो this is the direction. It can go in this way also, it can go in this way also. This is the direction of a spontaneous reaction. Okay, and अगर हम यहाँ पे इसमें बात करते तो this is delta G, ये G की बात करें, and here it is G naught for product. Okay, and अगर हम reactant की बात करें तो this is the G naught for reactant. Yes, it was a G naught for reactant. So ये जो value होती है, this is the value, this is called delta G naught. Are you getting it? Because it is यहाँ, this is we can say delta G naught for reactant. Any problem in this? Okay, so this is the direction of a spontaneous reaction. Okay, so in this way there is a relation given between this, that delta G जो होगा gives energy, total energy will be equal to delta G naught plus RT ln Q, where this R is equal to universal gas constant, T is equal to temperature, and ln I have told you that is the natural logarithm जिसकी value नहीं होती है, we have to convert it into what? Log to the base 10, natural logarithm, which will be equal to 2.303 log. I will convert it, and this Q is equal to reaction quotient. Reaction quotient. अभी reaction quotient क्या होता है? Reaction quotient is also concentration of product upon concentration of reactant. So what is it? This Kc. तो कहता है कि at equilibrium अगर हम ये ratio लेते हैं, if at equilibrium we take this ratio, then it is called Kc, equilibrium constant. But at any other condition other than except this equilibrium, so तब अगर हम this ratio लेते हैं, then it is called reaction quotient. Got it? At equilibrium, if we take the ratio of reaction concentration of product upon concentration of reactant, it is called equilibrium constant. But at any other condition if you take, ठीक है, other than except than equilibrium, if we take the ratio of concentration of product upon concentration of reactant, then it is called reaction quotient. Clear? So समझ में आएगा? Now if we consider like at equilibrium अगर हम देखते हैं, so at equilibrium the delta G will be 0. ये there will be no change, it will be like 0. Okay, so let me put over there. So it will be delta G naught is equal to minus RT ln Q, and at delta G not like 0, at equilibrium delta G will be equilibrium, and delta G will be 0 and Q will be considered as Kc. Somewhere you can see QC also. Okay, so there is no problem at the in this also, QC also. So QC will be equal to Kc. So in place of QC what I will write? Kc. ठीक है, or this value is not like we cannot calculate, so we can multiply by this and I can write 2.303 RT log Kc. Delta G naught is equal to this, and this is the formula that we have to note it down, and there will be question based on this. So that is the important thing. Hope it is clear. Is there any doubt? Okay, so that's it for this, and then at the last we will do the third law of thermodynamics, and then the chapter will be finished. So I will give you the questions. All the questions will be there in form of assignment only. There we will practice. Okay, and if you want to say, I can like one question I can write over here. So let me write the question. Let's do. I have written a question over here, like equilibrium constant Kp. Now one word Kp. Equilibrium constant is of two types. We will do in equilibrium chapter. If we talk about the concentration, then it will be termed as Kc, and if we termed as pressure, so for gases if you say, then it is Kp. Okay, but there is no problem. Instead of Kc you can write Kp here. There is some difference in that we will do in equilibrium topic. There is okay. So equilibrium constant Kp for the reaction X plus Y change into P plus Q at 300 Kelvin is this. यानी कि Kp is given 3.5 into 10 to the power of minus 4. Calculate the standard gas free energy, that means delta G you have to find. For the reaction temperature is given 300 Kelvin, and then you have to say under this given condition where the reaction is spontaneous, whether the reaction is spontaneous or not, that you have to explain. So let me find, for the reaction to be spontaneous, the delta G must be negative, isn't it? So if we will calculate it, if delta G comes negative, then we will say yes, it is spontaneous, and if it comes positive, then we will say it's non-spontaneous, and if it comes negative, then we can say yes, it is spontaneous, isn't it? So let me use the formula that we have. This formula here, it is delta G naught is equal to minus 2.303 RT log, and instead of Kc, what I will write, Kp. Okay, so this is 2.303 R की value 8.314. अच्छा, one more important thing, very important thing I'm going to tell you. Universal gas constant has 3 values. Okay, one is in joule per Kelvin per mole, another is in atm, third in bar. You don't have to worry about that. Only one value will be used in whole thermodynamics, and that is 8.314. Got it? Okay, so this is, if you want to write the unit to be so sure about that, you can write this is joule per Kelvin, this is joule per Kelvin per mole. Okay, and now temperature is given here 300, so this is 300 Kelvin. Now log, and this one is given 3.5 into 10 to the power minus 4. So we have to solve. Okay, so now this is Kelvin. Can I like, yes, Kelvin per Kelvin, cancel, done. So multiply it, and then what it will be, if you will multiply it, this comes, one second, we'll do later on. Okay, there is some problem, like let me solve this log. Okay, so can I write 2.303 into 8.314? You can do multiplication भी आप पहले करके रख सकते हो, there is no problem, into 300, and then I will write the unit last में. So there is log, this one is think, you might be like, you have watched that video how to find the log and anti-log. So in that it is log m into n, isn't it? So can I write here log m plus log n? Yes, can I write? Now this is log m power n. So what next I will write? 303 into 8.314 into 300, and this is log 3.5, and here I can write minus, this will come n log m, this will come over here, minus log 4 log 10, and log 10 की value क्या होती है? 1 होती है. Yes, so put the value of this 2.303 into 8.314 into 300, and log 3.5 की value आप रखो, and then this is minus 4. This will complete, ये पूरा complete 1 हो जाएगा. ठीक है, so log 3.5 minus, you will do this. So log 3.5 की value आ रही है, it is coming 0.5441. So let me write over here 0.5441 minus 4. So you just solve it, and then इसको subtract करो, and then multiply with all this. So you will get 19851.8 joule per mole. Got it? So delta G you are getting positive, isn't it? Since delta G is positive, so this reaction is not, so it is non-spontaneous. Got it? Any doubt? Yes? Now you can say that it is minus, here it will be minus, and this I'm forgetting about this minus sign. So this will be minus, and this will be minus, will be positive. Got it? Okay, so now the last topic of this chapter, and that is the third law of thermodynamics. Just to learn, just to know the things, nothing will be asked from this topic, so don't worry about that, don't be panic. like third law of thermodynamics. Third law of thermodynamics says that entropy of an ideal or a perfect crystalline solid may be taken as zero at absolute zero temperature. एब्सोल्यूट जीरो टेम्परेचर पे हम किसी भी आइडियल या परफेक्ट क्रिस्टलाइन सॉलिड का एंट्रोपी जीरो ले सकते हैं, कंसिडर कर सकते हैं, बिकॉज वी कंसिडर दैट देयर इज हाई फोर्स ऑफ अट्रैक्शन, सो मॉलिक्यूल डजंट मूव हियर एंड देयर, एंड दैट्स व्हाई वी कैन consider, we can assume. Okay, so what is the application of third law of thermodynamics? Third law of thermodynamics application ये कि we can find the absolute entropies of various substances at the room temperature. Although that enthalpy, the change in energy, we cannot find, but entropy we can find. Absolute entropy जो होगा that we can find. As for example, like how to get this? Entropy is a state function, so can I write delta S is equal to St minus Sg S naught. What is this? St is the entropy at the T temperature and S0 is entropy at the 0 Kelvin. Okay, so according to third law I have said that it will be 0, so that means S0 अगर हम लेते हैं तो it will be considered as 0, so St will be delta S, isn't it? Now in case of solid, St जो होता है that will come Cp dt upon T. कैसे आया? Think of it. Delta H is equal to T delta S. We know that delta H is equal to T delta S. So delta S is equal to delta S is equal to delta H upon T. Can I write? If we talk about the constant, so this is delta H is Cp dt. Can we say? Check करो, याद करो, देखो QV constant temperature, constant pressure, Cp dt. So वहाँ से आया, ठीक है, and upon T. Got it? So this is the calculation, and we integrate it, small changes. So 0 lower limit and upper limit this. Then we get this Cp and dt upon T. It will be T, yes, and this is like इसका integration करेंगे तो ln T. Cp will be constant, so it will come outside. So Cp ln T. ln में हम कुछ नहीं निकाल सकते, तो we have to convert it into log. So that will be 2.303 Cp log T. So this says that for the liquid and the gaseous substance, the total absolute entropy at given temperature will be the sum of the entropy changes which the substance has to undergo in order to reach the particular state. मतलब किसी भी liquid और gas solid का तो we can find, done like this. लिक्विड और गैसेस के लिए हम देखेंगे कि ये कहेंगे कि जो टोटल एंट्रोपी, टोटल एब्सोल्यूट एंट्रोपी जो होगी वो किसी गिवन टेम्परेचर पे, वो एक्चुअली सम ऑफ द एंट्रोपी चेंज, जितनी भी एंट्रोपी चेंज उसको पर्टिकुलर उस स्टेज तक आने में, वॉट एवर द चेंजेस वर देयर, वॉट एवर द एंट्रोपी चेंजेस वर देयर, उन सब का सम होगा, स्टार्टिंग फ्रॉम दैट like entropy at the crystalline solid, like means 0 से लेके. So it says that कि हम लिक्विड और गैस, क्योंकि सॉलिड से पहले लिक्विड में कन्वर्ट होगा, लिक्विड से गैस में कन्वर्ट होगा, सो वी विल कंसीडर ऑल दीज चेंजेस एंड द एंट्रोपी चेंज जितने भी स्टेप में होंगे उन सब का सम जाके निकलेगा. सो दैट इज अ थिंग like nothing, not so important. So but you should know this, what is the third law of thermodynamics, that's it. And here it is, sometime it can be asked in the question that can we find the absolute entropy? So yes, absolute entropy can be found for any substance according to the third law of thermodynamics. Got it? So this is the thing. So that's it for thermodynamics. Okay, and I hope you got it. So thank you, class.